Hey everyone. What we're doing today is we're looking at solving simultaneous equations in an algebraic method or an algebraic fashion, which is important for you guys to learn because you do have to do it using matrices on the test, but it's important that you understand the basic theory behind it. So there's two methods that we're gonna look at. So this first one is called substitution. Sorry, no, it's not. First one's called elimination, and the second one's called substitution. All right. So what I'm going to do is I'm going to use the elimination method, and I'll show you how that works to solve this set of equations here. There's 2x plus 2y equals 30 and 5x plus 2y equals 90. And then we'll do the other one. Okay, so step one, you've written your equations out. What you want to do is with the elimination method is you want to try and get rid of one of the two pronumerals, so either the x or the y. In this case, or I guess the easiest way to do this is you've got to identify which pronumerals have either a similar or the same coefficient or the number that's attached to it. So in this case, both of my y's have a 2. So this means that if I were to do one equation minus the other, I would actually get rid of those y's. So I'm going to do that now. So what I'm going to do is I'm going to put a minus sign in between them, right? Which means this one minus this one will give me my answer. So 2x minus 5x gives me negative 3x, and 2y minus 2y gives me 0, so I'm just going to leave that blank. And that equals 30 minus 90, which is negative 60. All right, so I'm left with negative 3x equals negative 60. So I guess what I can do to find out what that x is divide both sides by negative 3. I want to keep my sides equal. So that means that these two eliminate each other completely. I get left with x equals negative 60 over negative 3, which means x equals 20. Right? So now I've got this 20. I choose one of these two equations to substitute x equals 20 into, whichever one I think would be easiest. So I'll just do the top one. So 2 times, instead of x, it's now 20, plus 2y equals 30. So 2 times 20 gives me 40, plus 2y equals 30. So now I want to try and get this y on its own. So I'm going to get rid of this 40 by minusing 40 from both sides, which eliminates that, which gives me 2y equals negative 10. So now I'm dividing both sides by 2. So I want to get this y on its own, which means y equals negative 10 over 2, which means y equals negative 5. So that means my solution to this whole thing is x equals 20, y equals negative 5, or I can put 20, comma, negative 5, which is the point that these two lines intersect, where they have the same value for x and y. Okay, all right, now we'll do substitution. Substitution is a bit different again. So what I do is I have my two equations, and they need to be written in the form of one of the variables equals the other in some way. So see how this first one is a equals 4b? What that means is in the standard equation, which is the one below, I can replace a with 4b. Okay, so if I have 3b, can't write 3b plus 2 times, I'm swapping a for 4b, that equals 33. All right, so 3b plus, so 2 times 4b gives me 8b, which means 11b equals 33. So now what I'm going to do is I'm going to divide both sides by 11, which gives me b equals 3. All right? So now I can take that b equals 3 value and substitute it into this nice easy one to find out what a is. So a equals 4 times 3, which means a equals 12. So the point of intersection between these two equations is it's 12 and 3. All right? Yeah, cool. Well, a equals 12 and b equals 3. I guess we don't necessarily know what order these should be in. That's the basic idea behind it. Hopefully you enjoyed that. Take it easy.